Hello friends, today we are going to start chapter number 4, that is trigonometry. Now trigonometry you have already learned in 9th standard also. Let me consider that you know nothing and let me start from the scratch. So first of all, before starting this chapter and exercises actually, let us first make a list of the formulas and identities we need to know. Also the values of different angles we need to know. Let us study that first. Let us study the terminology in trigonometry, and after that we will move to actual exercise and problem solvings. Okay? Now first of all, we have to understand angles. Let us say this is a Cartesian coordinate system. This is the y-axis, this is x-axis. Okay? Now, how do you, suppose I tell you to draw the angle of 45 degrees. How you draw generally? Generally, we draw angles in anti-clockwise direction. Correct? That is called as the standard angles. So, this is the standard angle system. So, if this is angle theta, whenever you move to anti-clockwise, it is always called as positive angles. But if you draw this theta here, let's say this is angle alpha, this is negative angle. So generally we say this is the first quadrant, second quadrant, third quadrant and fourth quadrant. And you know that from here, from x, when we start, it is 0 degrees. From 0 degrees, this is 90 degrees. Okay? So here we have 0 degrees, you have 90 degrees. Since these are all positive values, I am writing with the black pen. This is 180 degrees, this is 270 degrees, and again this is 360 degrees. Correct? That means if I say that an angle of 120 degrees, where will it lie? So you can immediately say that since this is a positive angle, it will lie in second quadrant. Now, reverse of it. Now when we talk about the reverse, that is the negative angles. Now from this is 0 degree and this is negative minus 90 degrees. This is minus 180 degrees. This is minus 270 degrees and this is minus 360 degrees. Correct? So it is not difficult at all. First quadrant, second quadrant, third quadrant, fourth quadrant. When you take anti-clockwise, that will be positive angle. When you take clockwise, that will be negative angles. Okay? Now, one very important thing I want to explain to you, which will be useful in the physics also. You might have learned vectors. Okay? Now, for example, if this is a vector, okay, and this is r and this is theta. Okay. Now whenever such a angled vector is there, you have to find out the which is r sin theta and which is r cos theta. That means you have to find out the components of this vector. This is one component and this is generally called as abscissa or x-axis, and this is called as ordinate, that is y-axis. So how you will decide whether this is a r cos theta or r sin theta? How you will decide? Now by the books or by drawing simply, you can immediately say that yes, this is r cos theta. Okay? But don't be in the impression that your vector is always like this. Suppose if it is like this, and now you have to find if this is theta, now you have to find and components r sin theta and r cos theta. How you will find out? It is confusing. Okay, so that the vectors can be like this, like this, like this, any direction, any angle. So here in this case, I have seen even the engineering students get confused. They don't know how to consider r cos theta and r sin theta as a components. I will tell you very, very simple rule. It is not actually written rule, it is by experience. Now see, this is theta, This is angle positive angle. Where this angle will close? It will close here. Here. This angle will close here. And now C for close and C for cos. Just remember this sentence. C for close and C for cos. So this is my R cos theta, and definitely the remaining is R sin theta. So wherever it is, wherever the angle is, suppose you have this angle and you have to find out which is R cos theta, which is R sin theta. Now if this angle is given theta, and if you write this R cos theta, then it will be wrong. But let us apply our rule or sentence. C for cos, C for closing. Where this angle is closing? Here. So this is R cos theta and this is R sin theta. This rule for the students who are going for engineering, even to them this rule will be applied. Very, very important. Okay. Maybe in 10th standard you will not be make use of it directly, but whenever you are studying trigonometry, you have to remember this. Okay. Now when I say closing, now suppose instead if this angle is given alpha, now which is R cos alpha and which is R sin alpha? Simple. Where this alpha angle is closing, this angle is closing there. Okay. So now this is R cos alpha and this is R sin alpha. Simple? Very simple. Okay. Now let us learn the basic trigonometric identities. Let us say this is a right angle triangle. A, B and C. Now let us consider this is a right angle triangle and this is right angle of course, and this is given angle theta. Now the opposite side, what do you mean by sine? Sine is opposite side upon hypotenuse, that is AC upon CB. What is cos? Or here I will write opposite side upon hypotenuse. What is cos? Cos is AB upon CB. That is adjacent side upon hypotenuse. And what is tan? Tan is opposite side upon adjacent side. Or here we can write as AC upon AB. That is opposite side upon adjacent side. That's all. You have to remember only this. Because after that you have cosec. Cosec, now don't remember cosec as some side upon hypotenuse or hypotenuse upon some side. Don't by heart it in this fashion. This is just inverse of sine. Like that, sec is inverse of cos and cot is inverse of tan. Okay? You have to remember this with respect to angle theta. Now whenever you are solving the problems, you will be asked to find out, or it will be required for you to find out the values of sine theta, cos theta, tan theta when the angles are given 30, 60, 90, 45, 0. So there is a big table in your book. No need to by heart the table. Not at all required. Okay? You have to remember only two figures. Okay? The first figure, now I am telling you this, practice this figure to draw virtually in front of your eyes. Okay? So whenever you are asked to find out the sine theta, you should not draw those triangles and find out the figures. Okay? Virtually draw this figure in front of your eyes and the work is done. Which figure? The first figure you have to draw is, now you do along with me. Okay? Now in front of your eyes, see this right angle triangle. Close your eyes and just see this right angle triangle. Okay? Now top angle, consider or see there top angle as 30 degrees. Very simple. First see right angle triangle and top angle is 30 degrees. Okay? Now you have to write 1, 2 and 3. 1, 2 and 3. Okay? How you will virtualize? See right angle triangle, top angle is 30 and 1, 2, 3. Now instead of 3, you see root 3. That's all. This is the figure. Now, this is 30 means this must be 60. Now what is sine 30? What is sine? Theta I'll take 30. First we'll see all 30. Okay? We will see, or we will draw the table here in front of you. Okay? So we have sine, cos, tan, sec, cosec and cot. And we will take angles 30, 60 and 90. Okay? First 30. What is sine? Opposite side upon hypotenuse. So opposite side upon hypotenuse is 1 by 2. What is cos? Adjacent side upon hypotenuse. Adjacent side is this. So it is root 3 upon 2. What is tan? Opposite side upon hypotenuse is 1 upon root 3. What is sec? Opposite of or inverse of cos. So it is 2 by root 3. What is cosec? Inverse of sine. So it is 2. What is cot? Inverse of tan. So it is root 3. Very simple. Just remember this figure. Now let us write all the values of 60 degrees. What is sine? Opposite upon hypotenuse, root 3 by 2. What is cos? Adjacent upon hypotenuse, 1 upon 2. What is tan? Opposite upon adjacent, that is root 3. What is sec? Now don't see this figure. Sec, opposite upon cos, that is 2. Cosec, inverse of sine, that is 2 by root 3. And cot, inverse of tan, that is 1 upon root 3. Very simple. You don't have to remember this full table at all. Only this figure. Sometimes I suggest student that generally in the examination paper, the back side of the paper we write rough and we do some rough work there. So as soon as your paper starts, draw these two triangles. When a geometry paper, of course, draw these two triangles with the pencil there, so that in the course of solving the paper, you don't have to solve it. You don't have to draw it again. So you have to remember only this figure and only one identity, that is sine 30 is 1 upon 2. Now we have to find out the values of 90 and 0 also. Remember one more figure, that is sine 0 is 0. Okay, so I'll write sine 0 is 0. So sine and cos are here. So just go on writing the opposite things. If this is 0, this is 1. If this is 1, this is 0 and this is 1. Finished. Understood this? I am just remembering sine 0 is 0. So if it is 0, this is 1, this is 1, this is 0, this is 1. Opposite. Now what is tan? Now from here we have seen the sine and cos. One more identity we have to see, that is tan is equal to sine upon cos. Okay? Tan is equal to sine upon cos. So what is tan 90 will be? Sine upon cos is 1 upon 0. 1 upon 0. Many students will give answer 0. No, it is not like that. Whenever any quantity is divided by 0, the answer is not defined. It is infinity. So this is not defined. Tan 90 is not defined. But what about the tan 0? Sine upon cos, 0 upon 1 is 0. That's enough. For 90 and 0, only up to tan is enough. No need to find out the values of 90 and 0 for cot, sec, cosec. Okay. So here, without actually by hearting the table, just by remembering one figure, one simple figure, we have found out the identities, all identities for different angles. Once again, I will tell you how to remember this triangle, and then we will go ahead. Again I am telling you, just imagine one right angle triangle, top angle is 30, then 1, 2 and 3, that is root 3, that's all. When this is 30, it has to be 60 degrees. So this is your first figure you have to remember. Second figure you have to remember is, now you have to take right angle triangle again, but this time isosceles triangle, that this is right angle and this side equal to this side. If this side equal to this side, then these two angles must be 45 degrees, 45 and 45. Now these two sides are equal, so let us say 1, 1. And if these two sides are 1, 1, then what is the hypotenuse? Root 2. Root 2, simple. So what is sine 45? 1 upon root 2. What is cos 45? 1 upon root 2. What is tan 45? 1. Correct? You take any angle. Sine 45, 1 upon root 2. Cos 45, 1 upon root 2. Tan 45, 1 upon 1. So this is second figure. This is simpler figure. Now we'll go ahead. Now in this red region, we will write down all the important formulas and identities, so that whenever we are solving the examples, it will be handy to us. Whenever in the example some new formula comes, we'll write here. So at the end, you will have the complete list of all the formulas which are required to solve your trigonometry chapter. Okay. Now here I am not going to write that sine, cos, tan, that is cosec is reverse of or the inverse of sine. I am not going to write, because those are very simple things. I am not at all going to write even the values of 30, 60, 90, 45. Okay. Simply we will draw first two triangles here, which we have already learned. That is, this is 30 degrees, 1, 2 and root 3, and second was 45 degrees, 1, 1, root 2. Now all this identity we have seen for positive angles. Now let us see the sine, cos, tan for the negative angles. I am not going to show you the negative angles sec, cosec and cot, because you know how to find out once you know the sine, cos and tan. So now first we'll take sine minus theta, then cos minus theta and tan minus theta. Actually tan minus theta also I should not write here, because we know that tan is sine upon cos. So I will not write that, or let us say let it be there. So what is sine minus theta? Is minus sine theta. That means if you have sine of minus 30, sine 30 is 1 upon 2. So that will be equal to minus sine of 30, that is minus 1 upon 2. Okay. If you have cos minus theta, that will be equal to cos theta, and if you have tan minus theta, that will be equal to minus tan theta. This is obvious because sine upon cos is tan, so minus sine upon cos is minus tan. Trigonometric ratio of complementary angle, that is sine 90 minus theta, cos 90 minus theta and tan 90 minus theta. So when sine 90 minus theta, this is equal to cos theta. We know sine cos, cos sine. So whenever sine 90 minus theta, cos theta. Cos 90 minus theta, sine theta. And like we have sine cos, then what we say? Sine cos, tan cot, sec cosec. So whenever tan 90 minus theta, cot theta. Sec 90 minus theta, cosec theta, and cosec 90 minus theta, sec theta. So this is one group we have seen, negative angles. This is for 30, 60, 90 values, and this is for complementary angles. Okay, so these you will need when you are solving examples. Now one more term you have to remember, that is quadrantal angle. Now suppose this is A, B, C and D. Any angle whose vertex, now what do you mean by vertex? Remember one thing, when this angle is there, this is theta, positive angle, then the side from which the angle starts is called as initial arm. The side at which ends is called a terminal arm, and this distance P somewhere, this P is known as vertex. Okay, if the angle is negative, terminal arm will go in negative direction. Now the angles of which vertex lies on x and y axis are called as quadrantal angles. This may be there in the fill in the blanks or answer in one sentence for 1 mark. Okay, so if this is O, then angle AOB is a quadrantal angle, AOD, then BOD, that is also angle, though you see this is a straight line, this is an angle of 180 degrees. Then DOC and BOC, these are all quadrantal angles. Okay, now let us go ahead. Now I hope you have written this is important for you. Now we'll see the trigonometric ratio. So before that, just copy this so that you can by heart it later and keep it for your reference, because I am going to rub this now to write the trigonometric identities. No, I am not going to write the angle. Okay, for simplicity I will, instead of saying sine A, sine B, sine theta, while writing the identities I will simply say sine. Okay, so first is sine square plus cos square is equal to 1. After that, 1 plus tan square is sec square. Sine cos, then tan sec, cot cosec. So 1 plus cot square is equal to cosec square. Now before moving to exercise 4.1, let us see a few examples. For the angle in standard position, means anticlockwise angle, if the initial arm rotates 125 degrees, in anticlockwise direction, then state in which quadrant terminal arm lies. Now for this you should not draw the figure, okay, because this is very simple. You know that the first quadrant for the anticlockwise is 0 to 90, then 90 to 180. So if 125 degree angle, if it is rotating, then in which quadrant it will come? Second quadrant, of course second quadrant. I have already explained you what is called as the initial arm and what is the terminal arm. Okay, let's see one more. The terminal arm is in the third quadrant. What are the possible measures of angles? If terminal arm is in third quadrant here, from 180 to 270, what are the possible measures of the angle? Terminal arm is there. Now terminal arm is in third quadrant. So what is the possible? If the angle is positive, then it will be lies between 180 to 270 degrees. Or if the angle is negative, then it will lies between, this is 0 to minus 90, minus 9 to minus 180, minus 90 to minus 180. Or if it is positive, 180 to 270. So whenever it is asked what are the possible measures of angles, here they have not stated anything. The terminal arm is rotated clockwise or anti-clockwise. They have not stated anything. They have just told you that the terminal arm is lying in third quadrant. So if the angle is starting from 0 degrees, it can be positive, it can be negative. If it is positive, it will lie between 180 degrees to 270 degrees. If it is a negative, it will lie between minus 90 to minus 180 degrees. Okay, very simple. Let us see one more. The terminal arm is on negative x-axis. The terminal arm is on negative x-axis. So your terminal arm is here, is on negative x-axis. What are the measures of possible angle and what can you say about this or these angles? We know first of all there is quadrantal angle because it lies on the axis. So when it lies on the negative x-axis, first of all it is quadrantal angle. And what can be the value of this angle? If you take positively, it will be 180 degrees. If you go in negative direction, it will be minus 180 degrees. Okay. Let us solve one more example. Find the trigonometric ratios in standard position whose terminal arm passes through 3, 4. If the terminal arm is passing through, this is 3 and 4. If this is P, terminal arm 3 and 4. So definitely, if this is 3, 4, definitely this is 4, this is 3 and this is 4. If the terminal arm is passing through P, 3, 4, that means the Y is 4 and X is 3. So how will you find out the R? If this is angle theta, very simple, sin theta is 4 upon R. Sin theta is 4 upon R. Or we can say that sin theta is y upon R and cos theta is equal to x upon R. So R will be equal to y upon sin theta or R will be equal to x upon cos theta. So, and also we know that we can find out since this is a right angle, this is a right angle triangle, we can easily find out the value of R, that is R is equal to x square plus y square. This is just by Pythagoras theorem. So now what is asked? Find the trigonometric ratios in standard position. So we have to find out the sin theta, cos theta, tan theta, then sec, cosec and cot theta. But once we find out sin, cos and tan, cosec, sec and cot is very easy. Just inverse of it. Okay. So what will be? Sin theta equal to y upon R, cos theta is equal to x upon R, and what is tan theta? Y upon x. Now what is cosec theta? R upon y, sec theta R upon x, and cot theta x upon y. So you have to write, when such questions occurs, you have to write all the values of 6 angles. Next example is if the terminal arm passes through -4, -1, then in which quadrant does angle lie? Mind well, it is -4, -1, so it will lie in third quadrant. Suppose this is point P, -4, -1. Okay, so it will lie in third quadrant. To know in which quadrant it will lie, you don't need to draw all these things. Okay, -4, -1, just virtually you can understand that in which quadrant this angle will lie. Next example, if the angle theta is equal to -45, then find the values of sin theta and cos theta. Angle theta is -45, theta is equal to -45. So what will be? Sine of minus theta is minus sin theta. and cos of minus theta is cos theta. So what is sin 45? Sin 45 is 1 upon root 2. So minus sin 45 is minus sin 45 is equal to minus 1 upon root 2, and cos 45 is equal to 1 upon root 2. So these are the types of example which may be there in 4.1 and 4.2. So let us solve now exercise 4.1 and 4.2. Thank you.